did yesterday. It says the relationship between time and distance, y, can be represented by the equation y equals 2x. Complete the table and graph. So I need to complete my table. How would I do that? Ashton?
So it says y equals 2x. So you would take x times 2, 0 times 2, which is 0. 1 times 2, which is 2. 2 times 2, which is 4. 3 times 2, which is 6. And so on. And that would all simplify down to 2. Because 2 over is 2.
Okay, so good. We got our table filled out here. Then we would go over to our graph and we would graph this. So we would graph 0, 0. We would graph over 1, up 2, over 2, up 4. And we would continue this pattern and the graph should look like this. Okay, the graph would have a line through it because it's continuous and we're graphing an equation. It would have an arrow because this would go on until the end of time, until they stop doing this. So it would go in that direction. This one would not have an arrow going down this direction. This would be a no on this one. Why? Jacob? You cannot have that 0 time. So this one would not be into the negatives, but it would go up that way. Okay? All right, next question. What is the distance when time is equal to 15? So you're basically just using your equation here. We already know that x represents time. So you just take 2 times 15 and get 30 units. What is the unit rate of this graph? 2 to 1 or 2, either one. Because it's right, it's right here. Unit rate's the same thing, plus, look right here. It says here's 2. So every one, this doesn't tell us what it's in, 1 second, 1 minute, I don't know. But every time you go 2. So it's 2, or 2 over 1. All right, next one. Does the graph in exercise 1 represent a proportional relationship? James?
Yeah.
Yes, why?
Because it keeps on going. It's always the same.
Kind of, Eva?
Okay.
Okay, there you go. Because this is asking about the graph. The two things on a graph is that it's linear and it goes through 0, 0. Okay, so yesterday we looked at examples that didn't do that, or the last time I saw you, we looked at those. Okay, what about number 5? Do all linear graphs represent a proportional relationship?
No, because a linear graph can start at 2 or anywhere.
Very good. So if it doesn't start through 0, 0, I can still make a straight linear graph. But if it goes through here, then that's not proportional. Okay, we talked about that before, that might look like y equals 2x plus something or minus something changes it. Okay, all right, today we're going to talk about this idea of constant of proportionality, which is another fancy way to kind of say what we've already been doing. This is a big Algebra 1 concept that we're working with. And each day we look at it, we'll do a little bit more with it. Okay? So if you would say, Mrs. Grimm, what is constant of proportionality? I would tell you that we've already done it. It's right here. It is this idea that we're going to put y over x. And I'm going to give you several examples today why it makes sense to put y over x instead of x over y, like in real situations, so that it starts to make sense. So the first one here they're talking about is bricks. Okay, and they're saying if you decided you were going to become a bricklayer, Jeremiah said that was going to be his new profession. Okay, 1 brick is 20 centimeters. Okay, so it would make sense that if you put 2 bricks down, it would be 40. If you put 3 bricks down, it would be 60, and so on. It would make sense here to put this y over x to put 20 over 1, because what does this number represent? The total length of each brick. It would not make sense for me to put x over y, because does that tell you anything? No, that is weird, okay? This makes way more sense. You're like, oh yeah, that means the length is 20 for every brick. That makes sense. That's why we use it, okay? All right, so let's look at this one. All right, this one says the table shows the time it takes to pump gasoline based on the number of gallons pumped. What is the constant of proportionality? So again, this constant of proportionality is just looking for y over x, just like we did the other day. And it has to happen every single time. So what is the constant of proportionality on this one? James? 8. And it has to be 8 on each one. So if I put 136 over 17, it equals 8. If I put 96 over 12, it has to equal it on each one. And so my constant of proportionality would be 8. Does that make sense? Yeah. Okay. Makes a lot of sense. Good. Because they get a little harder. Oh boy. Okay, so here's another one that I like because it's going to explain why the y over x works. Okay, the table shows the amount of money raised based on the number of tickets sold for a charity concert. Okay, does it make sense that if you were going to go to a charity thing, that everyone would pay the same amount?
Yes.
Probably. Well, there could be different things. Okay, there could be in life, right? Like there could be better seats and worse seats. Let's change it to, let's say you're going to all go to the movies. Okay, and you're all going on Friday night to the 7 o'clock show. Same movie, no IMAX. Same, yeah, that same. Is no popcorn. Is everyone going to pay the same amount?
Yes.
Yes, everyone's going to pay the same amount. So there's going to be a constant of proportionality. What would the constant of proportionality be for you guys?
$5.
Really?
Yeah,
How would I go to
$5
movies? Nope, I said you're all going 7 o'clock Friday night, same movie, same thing. It's like $10. Is that the going rate? Not on Friday night, it's not. Okay, so it's like $10. So the constant proportionality would be $10. Now, if Gray goes and buys popcorn, is there now a constant proportionality? No, because he has spent more. Okay? Now, in this case right here, go ahead and figure out what your constant proportionality is going to be and tell me what it is. Okay, Hayden says it's 22.5. What does 22.5 mean in this situation? What does it mean?
$22.50. Yeah.
$22.50 per ticket. See, this is why we're putting y over x. Because it wouldn't make sense for us to get this, because we'd be like, well, this makes sense. This means it's $22.50 per ticket. I understand that. That is something that makes sense. Okay? All right. So now, let's go back over to our question. So does the table show a constant of proportionality? I would divide each one of these, and each one of these does come out to be $22.50. You would always want to check them all. Okay? And then it says you can sell no more than 2,500 tickets. Okay? Find the maximum amount of money you can make at your fundraiser. Eva.
So then you're going to take 2,500 times it by 22.
Yes. Okay? And so if I do that, what do I get? 56,250 bucks. Now, if you're saying, why would that be important? Well, if you were in charge of a fundraising event, you probably have to pay for the space that you're using. You probably have to pay for vendors to be there, whether you're going to have food or drinks or whatever you're going to have. You're going to have all this stuff. Your expenses cannot exceed anywhere close to that, or what's going to happen?
So you're not going to have any money for the charity.
You're not going to have any money for the charity. So budgeting and using things like this would be extremely important in real life. Okay? You'd want to know those kind of things. All right. Okay, so next one. First of all, just by looking at this graph, do you know if there's going to be a constant of proportionality? Yes, because it's linear and it's going through 0, 0. Remember, it doesn't have to start there, but it has to go through there. Okay, how would you find the constant of proportionality for this situation?
You look at the 1 and see what number that goes out to, and that's 80, and so the constant of proportionality.
Very good. Okay. Now, I want to look at two other things after she said that. First thing, I want to make sure you understand independent and dependent variables. Okay. It's exactly like it is in science. The way that I think of independent, dependent, anytime I think of what do I need to know first, and that's what's always the independent. Whatever I need to know after that is the dependent. So, like if I was, this is a male hummingbird. I don't know why it has to be male instead of female, but it's a male hummingbird, wing beats. Okay. Time is going to have to be there. Like at time 0, then I would say he beats 0. At time 1, I would say 80. I probably wouldn't say the hummingbird, his wings, I counted 300 beats. How many minutes is that? You know what I'm saying? Like that would be backward. So I would want to start off with my and then my dependent would be my number of beats. Okay? Which would mean that, again, I'm always putting y over x. If I look at this in table form, could we create a table out of this?
Yeah.
Sure. At 0,
0.
0. At 1,
80.
at 2,
160.
160. Because it's just right here. I'm just putting these, and I could keep going. Is it the same thing? 80 over 1, 160 over 2, all going to be the same. So lots of different ways to look at this. Okay, because we're going to need that here when we get to some of these other problems.
So bigger number usually.
No, it's not the bigger number. No. It's always the y over x. And you sometimes have to pick out your independent, dependent variables to figure out which one goes over which one.
So you have to go backwards and
Backwards in the alphabet. Okay, so that's the way you want to think about it. Yes. What about A? Well, we kind of already answered that. What is the constant proportionality where? So it was 80. And you guys pretty much already said that one too. All right. Okay, what about this one? Distance traveled. The graph shows the distance a cyclist traveled based on time. What is the constant of proportionality? Sam? It is 20 because it's right here. This would be 20 over 1. 20 over 1 would be 20.
you're just dividing.
Yeah, but you have to know which goes where. Okay. All right, those of you who think this is so easy. Okay. Oh. Well, you guys said it's so easy.
No, it's not.
Oh, no, it's not? Oh, you might need me.
No, so far it's
Oh,
you guys
so
just
far.
have to concentrate really
Okay.
hard and you get it right.
That's right. Okay. All right, you have a recipe that calls for 2 cups of flour to make 3 dozen cookies. Your friend has a cookie recipe that calls for 3 cups of flour to make 60 cookies. Are the constant of proportionality the same for the 2 recipes? Are the recipes for the same cookie? How do you know? Okay, so again, what did I say? I said independent is always what has to come first. So let's think about this. In life, do I go to the store and say, how much flour do I need? Or do I say, how many cookies do I want to bake?
How much flour do I do?
Flour.
It's not
Why
are
would
you
you
thinking
think
about
about
how many cookies you want to bake?
Okay. So Eva said, why would I want to think about how many cookies I'm going to make? Okay, am I going to make cookies for my kids? Am I going to make cookies for my whole family? Am I going to make cookies for the team? Am I working in the cafeteria and I'm making cookies for the whole school? That's a lot of cookies. So don't I need to know how much I'm going to make? And then after I say, okay, I want to bake 300 cookies, then my next thought is, then how many ingredients, right? Does that make sense?
Like a rough estimate of how many cookies.
Okay, but I have to know that estimate first, right? Like I don't just go measure my flour and go, I have 3 cups of flour. What can I make? I mean, I don't usually do that. That's not usually how it works. Okay, so this is going to be your number of cookies. I'm going to figure out how many I need. This is going to be the amount of flour I need. Because the amount of flour depends on how many cookies I choose to bake. The more cookies I need, the more flour I need. So the flour comes after the cookies. Okay, so then I'm going to put y over x. And let's look at the first recipe. The recipe calls for 2 cups of flour to make 3 dozen cookies. So I have to figure out how many cookies, right? So it's 36. So I'm going to put my amount of flour, which is 2 over 36. So that gives me 1/18. Now let's do the second one. So the second one is 3 cups of flour for 60 cookies. So what is that? 1/20. So are these recipes for the same cookie? No. They're different cookies because they call for different amounts of flour.